now that I'm not lying, we're actually going to do a 2 today. Now, so remind me the difference between a sector and a segment. Like what? So what are we really talking about here? Because today we're going to talk about areas of circles and sectors. What's the difference between a sector and a segment? Caleb?
A sector is a part of a circle.
What do you mean a part? That's pretty vague.
All right, so like a slice. You said it like a slice of pie.
Yeah, like a slice of pie.
And a sector is when you run a cord through. I don't know if it has to be specifically through a sector. I just know it has to be through a part of the circle, and that part that it creates, like the two separate parts. Like I think it's the smaller one, or I don't know. I'm not sure if you should cut a line through the middle, that'd be diameter. Well, I don't know.
You're on the right track. You're
It's
close.
the part thingy that like the thing it creates.
Brian?
Oh, alright. So a segment has the origin thing, and then wait, hold on. No, the segment does not have the middle point in it. Otherwise, it'd be the yeah. Alright. What? And then the sector has the midpoint. Segment is like pie.
Emma, try to clean this up for us.
I think a sector is the space between like the radiuses maybe going into the center, and the segment is the chord connecting two points on the circumference, and then the segment is the space in between the chord and.
Yeah. So, the sector is any slice. Can be under 90 degrees, over 90 degrees. Any slice of the circle, which is why we show this bigger than 90 degrees. We can see that we have, I guess we could kind of call it like an obtuse sector. The segment is the sector minus that isosceles triangle. So, we know that what we see in gray right up here is an isosceles triangle because both of those lines out are radii. So, that isosceles triangle taken away from the sector leaves us just the segment. So when we talk about sectors versus segments, please remember that sector is the entire slice, and the segment is part of the sector. So we know our normal area formula, pi r squared. Its area, it gets squared. If you are still getting confused between that and circumference, please realize that area gets squared, circumference does not. They're the same formula, except instead of using the 2 as a power, use the 2 as a multiplier. Sector area. Now, why? Can anyone figure out why they're doing what they're doing? They're taking theta, or the measure of this interior angle. So where they say measure of AB, they could have also said theta if they just say that this is always theta. So that's the arc measure. Right, so that's how much of it. Sorry, so it's not actually, they're really talking about this arc measure, but it's the same thing. We would just then take degrees off of it. Why are they doing that? This goes back to the same how we did arc lengths, dealing with figuring out that it was part of the circumference. Carmen?
Okay, so like pi r squared, that's like the area. So it's the area basically divided by the amount it's covering.
So this gives you what am I even really trying to say? It's the sector ratio taking the sector compared to the total. So we need to say like this sector is going to be half or a third or a fourth or a fifth or a sixth or some portion of the total. So this is just setting up what portion of your total. So essentially instead of like dividing or cutting into half, we're just multiplying by the ratio. So this value right here is just the ratio of sector to total. So really, I could honestly, so that's total area. This is sector to, I guess we could kind of say total. But it's really just however big your theta is, divide by 360, and then multiply. And then, so to find the segment, to find the segment, we would just then calculate the area of the triangle, because we're able to do that. We've done the trig to talk about all those different ways. And then whatever's left over, that would be your segment. So let's first Start right here with an easy one. So the diameter of a standard wrestling mat is 32 feet. So the radius of it is 16 feet. All right, well, that's pretty straightforward. What is the area of the entire circular region? Yes, I know. This is very basic to start. We'll use our area formula, pi r squared. Set up pi times, what's my radius here?
16.
16. We got to square my 16. I don't have that one memorized. 256 times pi. It does not tell me to leave my area in terms of pi, so we might as well compute it out to a decimal value. And we get 804.2477, you said? 77, so I'm going to round up to an 8. So straightforward, just remembering. So now what if the wrestling mat now has a 42-foot diameter? Yeah, sorry, my 4 got really close, and then I tried to erase my 4 and it caught some of the... $1385.4. 1385.4. So to do that again, the big thing here with circles, your area starts to get much larger, much faster because of that square component. When we square the radius first before we multiply by pi, a change of just a couple feet as my values get larger and larger makes a very dramatic change in the actual area. All right, so we remember how to find the areas of circles. Very easy, straightforward. If you didn't remember this, you shouldn't be in this class. That's one of the... So if you were a high school sophomore, this might be like, oh yeah, how do I remember that? But because you guys are in this class as 8th graders, this is like it should be real fast to just remember circle area. So now I have this one almost completely done out for you guys because I like you to have a reference to go back to. So my arc measure for GH is 52. 52 degrees, you go with the theta measure. So I take, sorry, not 52, 72. I don't know where I got that from. So 72 divided by your 360 will tell you the ratio or the portion of the circle. This is 1/5 of my circle. So if this was a pie, I'd have 5 slices of pie. So I want to know 1/5 of the circle's radius. So now is when we got to start doing something. What is my circle's radius? 15. So I'm going to set up 1/5 times pi times 15 squared. Well, I know that 15 squared is 225. That's one that you might want to keep in your back pocket there. If you know your perfect squares up to 15, you're pretty good. Like to just be able to quickly compute most things. So then I could just do 1/5 of the 225 and then times pi, or any order I want because multiplication is commutative. Either way, we end up with an area for the sector of, you don't compute it yet? 45 pi. Ooh, you're going to leave it in terms of pi. Sweet. 45 pi centimeters squared. Especially when we're leaving numbers in terms of pi, be careful to check for a label. People will fall into the trap of thinking, oh, it's in terms of pi, and then they think it doesn't need a label. Pi's a number, so it doesn't have a label. So please make sure to check for labels. Yeah.
So question, let's pretend that the ratio doesn't simplify anything. Would it be okay just to keep it as it is?
What do you mean doesn't simplify to anything?
So hypothetically, so you see it's 72 over 360.
So let's say this was 73 over 360.
Yes.
Would that make it unsolvable?
No, that wasn't my question. My question was, could I just do whatever? My question is, how would you solve that? No, that's a dumb question. Never mind. I just thought it out in my head. Yeah, I just said it out.
Do that,
I just thought it out.
and then just you can just leave the value in your calculator. This reducing to 1/5 doesn't make a difference, except then it's easy to talk about.
Alright, cool.
That section, that sector is a fifth of my circle. That's the only benefit that this does, as opposed to saying that sector is 72 360ths of my circle. That's kind of annoying, right? Yeah. Doesn't make it like better or worse. It just makes the math a little bit easier. Now, be careful also. They will sometimes ask you the complement question of not what's the area of sector GPH, but what's the area of like what's left over. So be careful with what question is actually being asked. So if we have a radius of 4 inches, a sector with a measure of 45 degrees, solve this on your own. Excuse me. And again, this ratio will actually come out to simplify nicely. Try not to look up here. Any questions on this one? We end up with 2 pi inches squared. Preguntas? What? Too early?
One class at a time. I can't handle more than that.
I was gonna try to remember to say how to say what time it was, but I forget. No, it's hold on. Right, but I was trying to. Right now it'd be dose 412 e quince uno, yeah, quince uno.
I got Spanish.
I think if Brand past 30, it's
it's
made out of
Yeah, see, I haven't told time in Spanish for a long time.
No, I'm still right.
Yeah, it's just which is
No, that's what we learned before we knew how to say
Yeah,
like,
he said
quarter
just
till.
because we don't know how to go.
Yeah, you don't. You're supposed to say that one.
has a Spanish neighbor, and they
Doesn't
asked
matter.
como te llamas. She said that despite the fact that she had gone to Spanish class, she forgot everything Spanish right then, and then she goes, bien, y tú?
So, here is the process solved out for solving a segment, because I wanted you guys to see exactly what we're talking about and have a good reference to go back to. So the first thing that we do is we approach it just as if we were solving for the sector. So we solve out the 60 degrees of the sector, pi times my radius squared, all of that's great. So the sector area is 54 pi inches squared. Then we look at the equilateral triangle that's formed. All right, I know that this is isosceles, but more than that, because it has the interior angle of 60, I know that it's equilateral. So that makes life even easier. I hate how they did this right here. I really wish, okay, so what they're doing is they're taking the triangle and coming out from C to the edge between A, B, but it would make a lot more sense if they just drew it like this and put A, B, and C to show you that really what we care about is we make a 30, 60, 90, or whatever relationship triangle. We can use the trig. If we don't have special right triangle, like this is 30, 60, 90, it's special right triangle. But we could use the trig if we don't have a special right. So let's look at this if we didn't have a special right. This is 9. From A to C, or sorry, from B to C is 18. A to C is also 18. So we need to know this height. If I'm looking at this right triangle here, what trig function could I use, Brian?
You could just do the 9 times 9 minus the 18 times 18.
What?
It's the how I
You're talking about Pythagorean?
Yeah, I don't
Okay.
know how to do the
Yes.
exact stuff.
But we want to review trig. Pythagorean's kind of 8th grade. We want to focus more on the trig that we can do right now. So you're right, we could. It's harder, though. Pythagorean takes more time than the trig. If you effectively know how to set it up, you can just punch it in, and in one calculation, you get your answer.
I have to think about all the special things. and stuff.
Okay, so you have to think. So that's your decision. Do I do the work, or do I turn on my brain? Emma, what trig function would you use?
Would that be 18 times radical?
So here's the first question we have to ask.
Divided by
What's my reference angle? So we have to decide, am I at this angle up here, or am I at this angle down here? So I can use either. Do you want to reference your 30 degree at C or your 60 degree at A? Your 60 degree? So if I'm going to reference my 60 degree at A,
Tangent.
tangent would be opposite and adjacent. So opposite, adjacent, tangent would work here. So we can use tangent, and this, of course, they show another way, but I want you guys to understand what we would do in any situation. I do tangent of my 60.
Wait, are you assuming it's 60?
No, we've been told.
Oh,
You could always use this and split it in half and derive the other triangle. Like, we'll do another
I didn't know
one.
we were referring to that one.
And then opposite over adjacent, my opposite's unknown, my adjacent is 9. So really, I just get 9 times tangent of 60 is my unknown value of x.
Oh, I got it. It's 15.588 or something other.
So
15.588.
So I got it. Except I used my math.
It's harder.
No, it takes less thinking. As you like. Yep.
So this right here, 9 radical 3, that's your 15.588. Like, they just derived it using the special right triangle rules. I wanted to avoid that because they won't always work out that way.
We're gonna do 5.9 because it's 5.88.
Yeah, I just ran out of board, actually. I was trying to write the other 8, but then it tried to drag my screen. It all depends on where my pen touches down. I can write anywhere, but I can't touch my pen down out there. That's the annoying part. If I touch my pen down, it screws up. Any questions? So, whichever way you use to find the area of the triangle, we then compute that the area of the triangle itself is 81 radical 3, or we would have a decimal answer there if we were using our decimal values. And then we just subtract away and find the remaining area that's left over. Any questions? We're just solving a difference problem here. So let's try this one. I want you guys to dive into it on your own. I'm going to give you a couple minutes, then we'll bring it back together and make sure that you're all set. So if you really want the step by step, you could first solve the area of the whole circle. Then find the area of the sector. Then the area of the triangle. Then subtract, find the difference.
So are we trying to find the...
Area of the segment.
Okay.
Yeah. But to get there, you have to find everything else also. Alright, you guys have a head start on me, and I'm going to take a method that takes a long time anyways. Yeah, Ryan's right. No,
Calvin, you're back.
Hey,
Yay.
good.
Love you,
Now we can actually have class.
I missed
I was
it.
just like doing a song and dance until you got back. I got you, Calvin, right here.
Where did you go, Calvin? Sick party. Parents' house party. I wish I would have looked at snakes during school time. Oh yeah. And then just chill at home for like an hour.
Hey, guys. Let's focus and get through this because I'm going to try to run us through the next lesson also. We'll eventually have a work day to catch up and compensate.
It's Friday.
Now this one is actually easier than I would like it to be. Why do I say this one's actually easier than I would like it to be for you guys? Megan? We don't really need the trig because my base and my height are already perpendicular. So I don't have to drop an altitude and find anything like that. So far, I found the area of the whole circle. Pi times radius squared. Then I found the area of just my sector, which, of course, if it's a fourth the circle area, I could have just jumped right to this, knowing that my 90 degrees makes it a fourth of the circle. Then I have found the area of my triangle, very easy in this case. And then the final step I need to do, Brian?
Subtract.
Subtract. So I want to take my 4 pi and subtract away the 8. And it says, get your answer to the nearest tenth. So I might as well derive out what my 4 pi is, which is approximately 12.56, but really...
Alright, well, my final answer was 4.6.
Meters
Meters squared. Meters squared. I remember that part.
Now, Brian, I appreciate your accuracy, but they did say the nearest tenth. So Caleb's got you on that
I had it
one.
further than that, but I just rounded up.
Any questions? All right.
Guys, this is like daily double in Jeopardy.
We are doing 8-3 also. I'll give you guys, we might just do practice day tomorrow.
Thank you,
Yeah,
Gus.
just to work on practice. Alright, so tangent lines. And actually, when you came in, I was already talking about tangent lines, so I forgot that we needed to do it too. But when a line is tangent to the circle, what relationships happen? I'm curious what we know about tangent lines before we dive in. Brian?
The radius in that line are perpendicular.
Yeah, so really, what it means to be tangent, there's a couple different definitions that you can think about. Because one, and this is where math gets complicated because you kind of have to like accept that some things are a little bit gray. One way that we talk about circles and the radius is that the radius is perpendicular to the edge of the circle, but that's accepting that if I zoom in far enough, I can look at the edge of a circle as a straight line, which it's not really, but if you think about zooming in super far, any curve will eventually look straight. So the radius is like quote unquote perpendicular. It's not really quite. But a tangent line is a straight line. So the tangent line is essentially the line that when it touches the circle, that's what that straight line would be if when I zoomed in super far on the circle, I took that little bitty point and made it a straight line. So right where that radius OP hits the edge of the circle, AB
Pardon the interruption. Casey Shannon, please come to the office. Casey Shannon to the office, please. Thank you.
Is now perpendicular to that. Likewise, if I have a line that I know is perpendicular to a radius, it in turn has to be a tangent line. Now, here's the relationship that is kind of mind-blowing, and most people have like a little bit of an issue accepting. If BA and BC are both tangent lines, and they share an endpoint on the exterior of the circle, they must be congruent. And this is where people are like, it's just that moment of like, well, why? Because if I drag B around and A stays a tangent point and C stays a tangent point, there's only certain places where that can actually exist so that this makes a perpendicular and that makes a perpendicular. So if I connect these, AO and CO are also congruent. So what else could I do?
No, it's a kite.
It makes a kite.
And
Because-
the radius is OC and OA.
I forgot my shapes. I forgot my shapes for a second. My bad.
So if OA and OC are congruent, AB and CB are congruent, got a kite.
That was close.
All right, so
The both shapes.
first two of these should be pretty quick. What do I know about this shape that isn't notated? That lets me solve for angle X. Keep going. No.
You can make it a
I
triangle.
know, but I've talked to you a lot. Ethan? I mean, so you know it's a kite. What else do we know? Do we know anything about...
I know. Angle. Split it into triangles.
Well, I could split it in triangles. I could split it here. I could split it there. I don't need to do that, though. Do you know anything about angle L?
It's right angle.
I was talking to Ethan, but yes, Carmen. This is a right angle,
Come on, Carmen.
so it's 90. This, go ahead and notate these on your paper, please. That's a right angle, so that's 90. So really, right now, I have 180 and plus 117 plus some angle X will equal 360 because it's a quadrilateral. Yeah. Yeah, which really means that if I look at just 117 and X, these have to equal 180. So X must be... Thank you.
If you just have a value of X technically would be 63.
Yeah, so technically we're talking X itself, I guess, would just be 63, since the degree symbol's on the X, but I always put the degree on anyways.
But that'd be double degree.
Degree?
And that'd be like
Degree squared?
Degree squared.
It feels like 30 grades.
Might as well start using cards to move quicker. Max, what else do we know here that lets us solve?
DE is perpendicular to DO.
Yeah, we know there's a right angle, so Calvin X turns into 52. Now here come the fun problems. So the CN observation tower in Canada,
I went there.
very, very sweet, unless you don't like heights, and then it's probably terrifying.
Is it taller than the Sears Tower?
Not certain. But it is about 447 meters, don't think about feet, think about meters, above the ground. A standard floor of a building will be approximately 3 meters tall, maybe 4. So this is taller than a 100-story building. So you ride an elevator up, and there's actually a restaurant inside of there. I think, if I'm thinking of the same thing, and it like spins slowly. So during the time of you eating, you get every single view because you slowly, like the whole restaurant just really. And I think it takes like an hour to make a rotation or something. So you barely notice that you're spinning. But every time you look out the window, it's a different view. So we're looking out the window from the CN Tower. This is not to scale. You will never see a scale drawing of the Earth that can actually mean anything. unless you're talking like Earth and other things relative size to the Earth. But if you're talking Earth and something on the Earth, you're not going to see a scale drawn. So, CN Tower, 0.45 kilometers, because they go ahead and round that to 450 meters. So we can just talk in kilometers, because the Earth's radius is 6,400 kilometers. So remember, a mile, I don't know how long a mile is in kilometers. Well, yeah, but that's feet. 5 tomatoes, 5280. How many kilometers make up a mile? It's 1.6. So 1.6 kilometers is a mile, which is why 5K is a little over 3 miles. So if we divided this by 1.6, we could get our mile radius, but I mean, you can also look that up. But just that, like, that's a lot of distance. So this is why we're saying this is not to scale, because there's no way that we could make something that minute to scale. We want to make a sketch. The length is 447 meters, about 0.45. So we need to determine what is the length of ET. Yes, phone home. So we need to find TE.
This doesn't have a question.
Yeah.
You know how they found out the radius of the Earth?
Calculations.
I think it's just like
You can do calculations, honestly. Certain things that you know.
But I'm assuming it's like an estimate, it's not an actual.
So here's the deal. What am I really making here? A right triangle. What part of the triangle am I trying to solve for? But what? A leg, right? So we know our hypotenuse, but our hypotenuse is 6,400.45. Then we would square that. That'll be equal to the a squared plus, because this is 6,400 also. But then just an extra 0.45, because that's your hypotenuse side, because it's opposite to your 90-degree angle. So that squared, then minus my other leg, or sorry, my one leg squared, will then give me the square of my remaining leg, which I'm going to call D because it is my distance to the Earth. Like when I look out of the tower, how far is my view going? Because, like, really, if we think about our eyes, like, all we're doing is taking in light. You could see forever. Like, when you look up at the stars and stuff, you are seeing forever. All we're doing is perceiving light. So there's no limit to how far we could actually look. You can see forever. What? Hold up. Back it up. Confused. So this is my hypotenuse squared minus my leg squared will give me my other leg squared. Right? This is just a manipulation of the Pythagorean. Yeah, this is just Pythagorean.
Okay, sorry. I got it now.
Yeah, well, Pythagoras. Look him up. He's sweet. He had a group of people called the Pythagoreans. I think they named themselves after him. So what I get there is, hey guys, 5,760. But that, of course, is the square of my answer. So really, I get 75.9. It's really 89599, blah, 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 whatever. But that is in kilometers. And if I want to talk about that in a more American style, we can divide it by 1.6 and get that is approximately 47.4 miles. So if you are in the CN Tower looking out, where you see the horizon, obviously you can look straight down at the ground if you wanted, but if you look as far as possible, you're looking about 47 miles. You're really high up. Like, think about how high above everything else you are. So if there's thingamabobs in the way, they're probably shorter. But those thingamabobs from that perspective look really, really small.
You could, I mean, you can still all you can do is see the horizon.
Yeah, like Brian. Use your brain.
Yeah, so approximately.
Brian.
Alright, flip over.
My math.
So try this on your own. Same setup, but now... Same setup, but now we're using miles. When we make the conversion and we use miles, we just let a little bit of error be okay. We say the Earth's radius is about 4,000 miles. So, if a person is on a plane 2 miles above the ground, which is actually not that high with how planes fly, if a person is on a plane 2 miles above the ground, what is the distance that they are looking out to the horizon? It's really hard to draw these, so please forgive my circle. Unless you're a very, very good circle drawer, these are very hard to draw. So, by the way, if you know how to type this into your calculator really carefully, you could do it all in one fell swoop, like one typing. If you've done your math, and if I've done my math correctly, I get 126.5.
Yes.
Now the last thing we need to do in about the 3 minutes that I have left is talking about if we need to find unknown values or if we need to check if something is a tangent. So in problem 3 here, we know that my line is a tangent because it makes the right angle. So how would we find x? But x is involved in the leg and the hypotenuse. What about it? So if I try to do what we've been doing, I would end up with x squared plus 12 squared equals x plus 8 squared. So let's go down this road, see what happens. I'd get x squared, and I'd get 144. I'd get x squared plus 16x plus 64.
You can square the x.
Why can't I? I have x squared on both sides. Chop them off. Just subtract x squared from both sides. It disappears. So now I could combine my constants by taking 64 away from both sides. That would take me to 80.
Wait, Mr. Hudson, where'd you get the 16x from?
So when we got to FOIL this. So this becomes, we've talked about FOIL a little bit. That's the only issue here, is you have to understand the FOIL process. The x has to multiply by the x and the 8. So I get x squared plus 8x. This needs to multiply by the x and the 8. So I get 8x and 64. So I end up with an x squared, 16 x's, and then 64. First, outside, inside, last. You gotta FOIL it.
But you can't.
So the process of FOIL, binomial times binomial. like really are distributing. This term has to distribute multiplication to here and to here. This term has to distribute its multiplication to here and to here. But the easy way we do that is to talk about FOIL. What's the product of my first terms? What's the product of my outside terms, my inside terms, and my last terms? Then these are like terms and combine to 16x. You're welcome. So if you guys are struggling on that at all, look up foiling. I guess we'll pick it up here tomorrow. Thank you much, guys. You should be able to get a pretty good jump start on your homework. So if you want to try 8-3, so here's what's up. Just grab one of each of these so you already have 8-3. Alright, cool.